North California scientists say a powerful zap from over 200 laser beams, lasting less than 9 billionths of a second, has advanced nuclear fusion research. The success of last month's experiment has sparked hope that hydrogen fusion may one day provide a plentiful and clean source of energy for the entire world. People have been working on this for decades, said Annie Critcher, chief designer of the experiment at Lawrence Livermore National Laboratory. I believe it has electrified the entire community. Inertial fusion technology Vice President Mike Farrell said the test was proof of principle that the technology can be controlled in a laboratory. We have advanced from theory to proof of concept. It still needs work to be replicable, but it's no longer science fiction. The experiment took place at Livermore's National Ignition Facility, which has 192 massive lasers. The lasers melted the gold, generating X-rays that heated a BB-sized hydrogen pellet. The fusion power burst produced over 10 quadrillion watts, or 700 times the producing capacity of the country's electrical grid. Defined as self-sustaining fusion processes, scientists believe that the heat from the pellet particles drives the atoms of hydrogen to fuse a burn wave, said Critcher. The outcomes were 25 times better than 3 years ago and 8 times better than prior spring experiments. On Twitter, one of the project's physicists stated the August experiment's energy production was 1,000 times that of a decade before. Until the implosion generates more energy than the lasers, pursuing fusion as a power source is a losing proposition. Officials at the lab are optimistic that the numbers will continue to improve. It's a much greater output and self-sustaining, Critcher added. Officials at the lab said they made the statement because word of the experiment was spreading quickly. Critcher is very confident that further studies will yield consistent results. Even doubters were awed. I am surprised, said Stephen Bodner, a veteran plasma physicist and long-standing skeptic of the NIF. Achieving ignition and break-even is close enough to call it a success. In other words, it shows skeptics that the laser fusion hypothesis is sound. Nuclear fusion is not the same as commercial nuclear power plants like the now-closed St. Onuphar Nuclear Generating Station. Fusion, on the other hand, involves colliding hydrogen nuclei and fusing them into helium atoms, releasing enormous amounts of energy. Since the 1950s, scientists and researchers have sought to exploit nuclear fusion as a source of electricity. General Atomics technicians selected and prepared the pellet, as well as 2 pieces of equipment used in the Livermore experiment. A successful commercial deployment of fusion energy could mean a lot for humanity. In seawater, you can virtually distill the ingredients required for fusion, says Farrell. And you would suppose if these power plants were available globally, there would be no energy issue, and then poorer regions could develop. While the Livermore announcement is encouraging, an era of futuristic, clean-burning nuclear fusion power plants is not imminent. In research facilities, fusion power has only been generated for short periods of time. The August experiment, according to physicist Arthur Turrell, was a milestone, taking nuclear fusion from concept to reality. There's a long path between demonstrating that your facility can create more energy than it consumes in commercialization, Turrell said. He suggested it's time to stop saying fusion energy is 30 years away. Like any technological advancement, it depends on our investment and effort, Turrell added. We don't just set a timer and wait for things to happen. This will happen faster if the world wants it to happen faster and spends more money on it. Interestingly, the National Ignition Facility's main focus is on nuclear weapons research, not energy development. When the U.S. stopped underground nuclear testing in 1992, energy authorities advocated using the site to test the country's nuclear arsenal without actually detonating any of them. Despite the outstanding results, the National Ignition Facility lasers are not considered suitable for use in a commercial nuclear fusion power plant, since they cannot evaporate multiple hydrogen pellets per second. Creating energy with super-strong magnets, which would create an extraordinarily hot, energy-producing plasma, is regarded as more promising. One of the most famous projects using magnetic confinement is the International ITER facility in southern France. The central solenoid, a major component of ITER, is being shipped in parts from General Atomics to Cataract, France. The first 110-ton module arrived in France on September 13, with 6 additional shipments scheduled through 2023. ITER won't be a working fusion plant. Rather, it seeks to pave the path for fusion-powered power plants. Despite some cost overruns, ITER should start up in 2025. And with that being said, it's time to end our video. What do you think about this upcoming nuclear fusion? Let us know in the comments.